Hello everybody, today we're going to talk about factor by grouping. And we're specifically going to use factor by grouping when it comes to quadratics, trinomials, three terms that are a quadratic. And so you probably have seen before a method that is maybe a little bit easier for factoring quadratics. But the nice thing is that while there is a shortcut method that some people use, this method will work for every quadratic. And sometimes the shortcut, that's not true, a lot of times the shortcut only works for certain quadratics. So anyway, to be able to do this factor by grouping, you have to have one skill. You got to be able to do basic factoring, which I believe all of you can handle at this point. If you see a binomial like this first one, 4x squared plus 10x, you have to be able to look at that and say, what do those two things have in common? Realize that they both have a 2x in common. I could factor out that 2x, which would leave me with 2x plus 5. Because 2x times 2x gives me 4x squared, and 2x times 5 gives me 10x. And in the same way, I should be able to factor this second one, this 27y minus 3y cubed, and say they both have a 3y in common. And then that would leave a 9 minus y squared. Okay? And so because 3y times 9 would give me 27y, and 3y times y squared would give me 3y cubed. Okay, so that's the basic factoring that you have to be able to do. And what we're going to do is we're going to take that idea and we're going to apply it to these trinomials. And as I said, I know there's probably another method that you have talked about, you have learned, you feel like you might even be more comfortable with. And I'm just going to plead with you to put yours on the shelf for a second and try my method. If you don't remember yours, that's okay. I'm going to show you this easy method that will work so basic and so simply for all of them. It's not just a shortcut that works for some of them. It works for all of them, okay? So what I'm going to do is I'm going to start with a trinomial, a quadratic that looks like this x squared plus 6x plus 8. And there's a couple things. First, I want to point out that the leading term, the x squared, has a coefficient, an understood coefficient of 1. Okay, and that's kind of silly, but we're just going to go, remember that does have actually a 1 there. And so what we're always going to do is we're always going to multiply that first coefficient and that last term, okay? And now when that coefficient is 1, well, 1 times that other number is just that other number, so that's not complicated. 1 times 8 is 8. But ultimately, that's just this little trick that we are going to do. Right now, it doesn't really matter because we didn't have anything there except a 1. So we're going to say, what are the factors of 8 that add up to be 6? So what are the two numbers that multiply together give me 8, but when I add them, I get 6? And the answer would be 2 and 4, because 2 times 4 is 8, and 2 plus 4 is 6. And so what we're going to do is, instead of skipping all the way to the end, we are now at this point going to split up that 6x into those two values. We can say x squared plus 2x plus 4x plus 8. You might say, well, wait, where did the 2x and the 4x come from? But you know that 2x plus 4x is just simply 6x. All we did was we took that 6x and we split it into two terms. And now what I'm going to do, that wasn't the factor by grouping. That was just taking that middle term and splitting it into two terms. Now I'm going to factor by grouping, meaning I'm going to factor just those two terms, and then I'm going to factor just those two terms. And watch how this works. What do the first two terms have in common? They have an x, which then if you pull out that x, that leaves you with x plus 2. And what do the second two terms have in common? Well, they have a 4 in common. If you pull out a 4, you're left with x plus 2. And now I notice I've got this x plus 2 here and this x plus 2 here. And what we're going to do is for just a second, we're going to pretend that that's a different variable. Because right now it's x plus 2, and that's kind of a complicated thing. We're going to pretend that that's just a big fat w, okay? And so just for a second, I want you to pretend that instead, this really just says x times w plus 4 times w. And I asked you to factor that. How would you factor that? Well, you'd say, well, they both have a w in common. And you would take the w out, and you would be left with x plus 4. Now, we're going to do the exact same thing. But instead of having a w, we have this x plus 2 thing, this binomial. And so we're going to factor out that x plus 2 to the front end, x plus 2, times whatever's left, x plus 4. And there you go. And that is the factored form of, that's the factored form of this quadratic right here. You can go to right here, okay? Let's try it again. Here's another one. Okay, again, we go, what's that leading term? Well, the leading term is 1. 1 times 6 is just 6. So we're looking for factors of 6 that add up to be 5. And so the two things that multiply together to give me 6 are 2 and 3, but when I add them, I get 5. So I'm going to say, well, I'm going to take that 5x squared and break it into those two terms. It's 3x and 2x. And now I've split it. And so then I'm going to factor these first two terms. What can I take out of those? I can take an x, which leaves me with x plus 2. Once again, I've got exactly x plus 2. It's kind of funny. That's just a coincidence. That it's not a commonality. That should not be a theme you're looking for. I can take a 3 out of the next two, which leaves me with x plus 2. And now I can factor out this x plus 2 to the front, x plus 2. And what does that leave me with? X plus 3. X plus 3. And so that's the factored form right there. Okay? All right. Now I want you to try another one and try to do it on your own. I'm going to ask you to pause the video. So here's the next one. And try to see if you can do this one on your own. Okay? Same idea. So I'm going to leave the work that we did right there. And just go ahead and hit the space bar, pause the video right now for whatever, 10, 15 seconds, and try to do this one on your own. Okay, now let's try it together. Okay, so again, I go, what's that leading term? Well, it's just a 1. 1 times 10 is 10. Okay, and I'm looking for factors of 10 that add up to be 7. And I think of 5 and 2. Okay, and so what I'm going to do is I'm going to say this is... this is going to be x squared plus 5x plus 2x plus 10. I split the 7x into these two terms. And now I factor the first two. I can take an x out, which leaves me with x plus 5. I can take a 2 out of the next couple terms, which leaves me with x plus 5. And now you can see, I'm going to pull that x plus 5 out to the front. And that leaves me with x plus 5 times x plus 2. And that's how you get. Yeah, you get from here to here. Okay? Now again, some of you might say, yeah, but I know a little bit of a shortcut, and that's fine. And you can use your shortcut on these in a minute, but just not yet. Okay? Because right now, these are done more simply this way, and it's real logical, and it's real easy to see how we get the answers. Okay, and this is no different if it was subtraction. Here is one where you got negative in the middle. Okay, and so you say, well, again, there's this 1 out front. 1 times 12 is just 12. What are the factors of positive 12 that add up to be negative 7? Well, that would be negative 3 and negative 4. Those, when I multiply them, I get positive 12. But when I add negative 3 and negative 4, I get negative 7. So I can split that negative 7x into those two values. I can say x squared minus 3x minus 4x plus 12. Now, the only thing that's different here is when your middle sign is negative, you have to factor that negative out. That's a rule. Whatever that middle sign is there, you always factor that out. Now watch. So out of the first two terms, what do they have in common? Just an x, which leaves me with x minus 3. And then the next two terms, what do they have in common? And the answer is negative 4, which will leave me with x minus 3. You might say, wait, why minus 3? And the minus 3 is because a negative 4 times a negative 3 gives me a positive 12. So that's why I always have to factor out that negative. If there's a negative in the middle here, I always bring that out, always. Okay, and now you factor out that x minus 3 to the front, and you get x minus 3 times x minus 4. Okay? And same thing. There's nothing different about this. It's the same situation every time. Okay, the only thing different is that I'm factoring out that negative on the second set of terms. So here, factors of positive 15 that add up to be negative 8 would be negative 5 and negative 3. And so I'm going to say x squared minus 3x minus 5x plus 15. I can take an x out of those first two terms, which leaves me with x minus 3. I can take a negative 5 out of those next two terms, which leaves me with x minus 3. So then I bring out that x minus 3 to the front end, and I'm left with x minus 5. And there you go. There's my factored form. Okay? And now you guys try this one. I got x squared minus 9x plus 18. You guys try that on your own. Try it by factor by grouping. Hit the space bar. Pause it right here for about 5, 10, 15 seconds. And then we'll come back to it. All right. Let's give it a try. Okay. So with this one, factors of positive 18 that add up to be negative negative 9 would be negative 6 and negative 3. If I factor out an x out of those first two terms, I'm left with x minus 6. If I factor out a negative 3, I'm left with x minus 6. So then I get x minus 3 times x minus 6. There you go. Okay, and it's that simple. Now it's no different, it's no harder, maybe just a different feel to it, when sometimes your last term is negative. Because what that does is that means you have one positive and one negative. And so this middle term is now like the difference between those two. In this situation right here, it would take a positive 6 and a negative 4 to multiply together to give me a negative 24. And when I add a positive 6 and a negative 4, I get positive 2. And so that's the two values that I split this into. I would say, okay, x squared plus 6x minus 4x minus 24. Now again, I notice I have that negative sign as the middle sign, so I'm going to factor that one out. I can take an x out of the first two terms, which leaves me with x plus 6. Take a negative 4 out of the second two terms, which leaves me with x plus 6. And then at that point, take the x plus 6 out to the front, and I'm left with x plus 6 times x minus 4. Okay? No different. All right, what I want you to do now is I want you to try these next two on your own and see if you can handle them. So hit the spacebar, pause the video here for about a minute or two, and see if you can do these. All right, let's give them a try. Okay, this first one, factors of negative 10 that add to be negative 3. That would be negative 5 and positive 2. And so I'm going to say x squared minus 5x plus 2x minus 10. All right, and I can take an x out of the first two terms, which leaves me with x minus 5. I can take a positive 2 out of the next two terms, which leaves me with x minus 5. I bring the x minus 5 out to the front, and I'm left with x plus 2 right there. Now, you might have done it differently. You might have said, well, wait, I did x squared plus 2x minus 5x minus 10. And see, here's the neat thing. It doesn't matter because math is true. You can switch those two terms and watch what happens. If I factor out an x out of these first two terms, I'm left with x plus 2. I have to factor out a negative 5 out of the next two, which leaves me with x plus 2. I bring that x plus 2 to the front, and what am I left with? X minus 5. And so how is that different? All it did is it just changed the order of the two terms, of the two binomials. I just multiplied in a different order. But we know that you can multiply in any order, and it still doesn't change it. And so same thing here. With this one, you might say, what are the factors of negative 24 that add up to be negative 5? And I would say 8 and 3, negative 8 and 3. So I'd say x squared minus 8x plus 3x minus 24, which then you can factor an x out, which leaves me with x minus 8. You can factor a 3 out, which leaves you with x minus 8. And then you've got x plus 3. Well, I'm sorry, rather, you bring the x minus 8 to the front. It, again, order doesn't matter because I'm multiplying times x plus 3. All right, these are straightforward and simple. Now, again, you might be of the group that says, wait, I start with the beginning thing and I just go straight to here. And I get it. And that works for these. And you can do that with these. But you cannot do that once I change that coefficient on the leading term. All of a sudden, that method no longer works. But my method still does. Watch this. We take that first term and multiply it times this 9. Now that first term is not a 1. This time it's a 2. 2 times 9 is 18. Factors of 18 that add up to be 9. 6 and 3. 6 times 3 is 18, but 6 plus 3 is 9. Watch this. So then I go 2x squared plus 6x plus 3x plus 9. I do my method, this factor by grouping. I split that middle term into the two terms and now factor just these two. I can take out a 2x, which leaves me with x plus 3. Out of these second two, I can take out a 3, which leaves me with x plus 3. Now I bring that x plus 3 to the front, and I'm left with 2x plus 3. And it still works. Whereas if you tried your method and say, well, wait, the factors are 6 and 3, won't they just, oops, no, it doesn't work that way. You got to do factor by grouping when there is a coefficient. Now, if you know the shortcut that I'm referring to and you can go straight from here to here, that's fine, but it will never work when there is a coefficient on that first term. Okay, let's try it again. We have 3x squared plus 11x plus 10. Okay, the very first thing we do is we say, what's 3 times 10? Well, that's 30. What are factors of 30 that add up to be 11? 6 and 5. Okay, 6 times 5 is 30, but 6 plus 5 is 11. So then I factor that out. I say 3x squared plus 6x plus 5x plus 10. Factor those first two terms. I can take a 3x out, which leaves me with x plus 2. Factor these next two terms. I can take a 5 out, which leaves me with x plus 2. And now I bring out the x plus 2 to the front, and I'm left with 3x plus 5. 3x plus 5. All right. The only thing that I want to point out, and this is a hint to make it easier, not harder, is that when you split this into these two terms, this 11x, typically, whichever one has more in common with my first term, I put first. Now, it doesn't matter which one you put first, but it's a little bit easier to do. Notice 3x and 6x have more in common, and 5x and 10x have more in common. So it's just a little bit easier to do it that way, okay? That's all I'm saying. It's just a little bit easier to do it that way. It doesn't, you could put the 5x first, still get the right answer, but it just tends to work out a little bit easier. Okay, you guys try this one, hit the space bar, pause the video, and we'll come and try it in a second. All right, here we go. So this one, I go 2 times 25 is 50. Factors of 50 that add up to be negative 15. I'm thinking negative 10 and negative 5. So I'm going to say 2x squared minus 10x minus 5x plus 25. What can I factor out of these first two? 2x, which leaves me with x minus 5. What can I factor out of these next two? I know I always factor out that negative. So I pull out a negative 5, which leaves me with x minus 5. I bring out the x minus 5 to the front, and now I'm left with 2x minus 5. 2x minus 5. And that is factor by grouping. Good luck.